is Student Notes 5.7, and we're doing double angle properties, and this is day 2. Okay, we actually only have 3 proofs to do, and I'm actually going to start on the hardest side. So that's what I'm going to write down first. So this is 2 tangent of x over 1 plus tangent squared. Okay, remember you will always start with writing down where you're going to begin. Okay, so make sure that you have out your formula sheet so that we can reference that and look back at that anytime we need. Okay, so it looks like we're going to be trying to get to this right here. And if you remember this by anything at all, this is our double angle properties. Okay, so let's go back and look at that. So we're trying to get to sine 2x. So that's actually on the back side of your sheet. And sine 2x, this is our goal right here. We're trying to get to 2 sine cosine. All right? Okay. So if you don't know where to go from here and you have no clue, let's just start changing things. Okay? So we have a 2. And you know that tangent is equivalent to sine over cosine. So let's change that. Okay? All right. Let's see. The next thing right here. If you remember anything at all, I know it's been a while, but this 1 plus tangent squared, I hope that this looks familiar to you, and I'm going to go back to our sheet. 1 plus tangent squared. Right here, this is a Pythagorean identity. 1 plus tangent squared. Okay. You don't use this a lot, but since it's there, I'm going to go ahead and use it. Okay, so that is equal to secant squared. Now, that is on the bottom, so I'm just kind of writing this all out next to each other. My 2 is actually over 1. This was my tangent, and then this is equal to secant. Now, it's on bottom, so I'm going to have to put a 1 over it. Okay, that's equal to secant squared. Okay, so let's see what we can do with this. I still can't do anything with it, but I do have a secant down here on bottom, which might help us out. So what is secant actually equivalent to? Well, I still have my 2 over 1. I still have my sine x here, and I have my cosine. Whoops, I forgot my x up there. I have my cosine x here. Well, I know secant squared is actually equal to cosine. So I can actually leave that or change that to cosine squared x and put that over 1. Okay, well this actually is going to help me out, which makes this nice. I can actually take out one of my cosines. So this leaves me with a 2. I've got a sine here. And I now have a cosine, and I have nothing on bottom. And that looks like we're done. This is equivalent to what I needed. I needed my sine of 2x. And that should be our answer for our first proof. Okay, let's try our second one. Okay, I still think I'm going to start with this hard side. It looks kind of scary, but I think we can do it. Okay. All right. So let's write down where we're going to begin. So this is a secant squared x over the 2 minus secant squared x. Okay. I'm going to work this a way that I think some of you might do it first, and then I'll try to work it a second way for you. Okay. So since we just used a Pythagorean identity, I'm actually going to do it that way again on this one. So what is secant squared equal to? Well, since we just used it, we know that that's equal to 1 plus tangent squared x. And the same down here. We can replace that. So this is 2 minus, this is equal to 1 plus tangent squared x. Okay. So let's see, we can distribute this on the bottom. So I still have the 1 plus tangent on the top. And on the bottom, that's just going to be 2 minus 1. So that's just going to be 1. Whoops. 2 minus 1. Yeah, that's still 1. And that gives me tangent squared x. Okay, sorry about that. I forgot to distribute the negative here. So this is actually a negative tangent right here. So don't forget to distribute that right there. Okay, so it looks like I really have a lot of nothing right here. So how about we change our tangents? So this is going to be 1 plus. I know tangent is equivalent to sine over cosine. So how about we do sine squared over cosine squared x over 1 minus sine squared x over cosine x. And so since we have a 1, how about we make that the magic 1? So that's going to be cosine over cosine on both of them. I'm going to have to come up here. I'm running out of space. So that's going to be cosine squared over cosine squared. This is going to be our plus. That's going to be sine squared over cosine squared. And that's all over. I'm going to do the same thing on the bottom. So that I've got my common 1 here, cosine over cosine. Okay, minus sine squared over cosine. Okay, so on the top, I'm going to go ahead and combine these so that I've got cosine squared plus sine squared. I hope y'all are starting to see something. Over my common denominator, which is cosine squared. Same thing on the bottom. Cosine minus sine over my common denominator, which is cosine. Okay, so I hope you noticed that both of these have the common denominator of cosine. So now I can divide by the reciprocal. So if I do that, I now have cosine squared plus the sine squared over cosine squared minus sine squared. Okay, hopefully this right here looks familiar to you, and that's actually an identity, the Pythagorean identity, original. So that is 1 over. This also hopefully looks familiar to you. This is a double argument right here, and it's actually the one we need. This is the one for cosine of 2x. And 1 over cosine is actually equal to our secant of 2x. And that should be our answer. Okay, now I know that was kind of long and drawn out. I just figured that might be a way that most of y'all would see that. Okay, so I'm going to draw a line here. And if you've got room on the back of your paper, you could do this. I'm going to show you another way that you could do this proof. Okay, I'm still going to start on the right side. So I'm going to do secant squared x over 2 minus the secant squared x. Okay, so one way that I might see this is I might change secant to 1 over cosine. Okay, so this would be 1 over cosine squared x. Now remember, I can go ahead and put that on bottom because that's just a fraction. I'm actually going to leave the bottom as is. Okay. That's a squared. Okay, so now that I have that, I'm actually going to go ahead and distribute this. Okay, so this is going to be a 2. Distribute this in and distribute this in. Okay, so that would be my next step. And this is all on the bottom, so I have to leave my 1. So this should be a 2 cosine squared x. And this right here is going to be minus cosine squared times my secant squared. Okay, now this right here, cosine times secant, those are reciprocals of each other. So this actually right here cancels out and gives me a 1. Okay, so 1 over 2 times cosine squared x minus 1. Okay, well, this right here is a form of your double argument. So I'm actually almost done. So this would be cosine of 2x, and again 1 over cosine of 2x is your secant of 2x, which is where we want it to be. So there's 2 different ways, and of course you might find another way to do it as well. Okay, let's look at our last one, see if we can find a way to do it. Okay, this is one way I found. How about we start here on the right side? So tangent x cosecant squared x, and that's over 2. So I'm going to start on the right side on this one. Let's see, I probably would change tangent. So let's see, that's going to be sine x over cosine x. I probably would also change cosecant. And remember, tangent, that's just a fraction, so I'm just pulling everything out next to each other. So cosecant is 1 over sine squared. Okay. And since my 2 is on the bottom, that's a 1/2. It looks like, oh, that makes it really helpful. So that sign's gone, and then one of these signs is gone. So everything is on the bottom. So I've got 1 over. I'm going to go ahead and put it in order. I think I see something. So this is a 2. I've got a sine x, and I've got a cosine x. So this is a double argument. This looks like my sine argument. So this is sine of 2x. And I needed cosecant. So I should be done. Cosecant of 2x. Because that is a reciprocal.